So good morning, everyone. Can you hear me well? Okay, that's great. As Paul Leisel has kindly introduced, we are very keen to celebrate the Rare Disease Day here at Royal Holloway for a variety of reasons, which I will introduce. I will also give you an idea of what you're going to be doing during the day, and mainly really why this is so important. I think it's important also to for you to be clear of what are my credentials to be discussing this topic with you today. So I have a variety of roles. My two professional ones, so to speak. I'm a professor here at Royal Holloway, and I'm the editor of a journal called Gene Therapy, which is one of the leading journals in this particular scientific field. But I also have two honorary roles. I'm the treasurer of one of the learned societies in the field, the British Society for Gene and Cell Therapy, and I'm the chair of the Genetic Alliance UK. It will be my pleasure today to introduce the next speaker in a few minutes, who is actually the chief executive of this charity, the Genetic Alliance, and she will tell you how important this umbrella organization for patient societies is. This is an outline of my lecture today, so you know what I will be discussing. What is a rare disease? What is this day? Why is this important at this place, Royal Holloway? I will take you back a little bit about genes and diseases to remind you the molecular basis of this, and we'll discuss a little bit about mutations, and then the progress that is being made, but also some of the very important, perhaps social issues in the field, the pricing of the medicines that are coming along. And I'll finish with a note on the inspiration that we can draw from all this. So a little bit as Paul was introducing, there is a way to define rare diseases, and different countries or different groupings of countries have a different definition. But in the European Union, a disease is rare if fewer than 1 in 2,000 people are affected. The issue is that there are many rare diseases. We don't actually know how many. Many are actually being described on a weekly basis. So there are somewhere between 6,000 and 8,000. They affect 7% of people because there are hardly any treatments for these people. They take a disproportionate part of the health budget, about 20%. In addition to that, most of those diseases affect children, and 30% of those will die before age 5, which is terribly sad. And most of us really do not know about this. So something really important is to raise awareness about all this. There is a list of rare diseases, as you can imagine, updated very, very regularly, and these are the first 10 diseases on the list. What I want to give here is just a sense of how many there are. So is anyone brave enough to try to guess how long will it take to read the rare disease list aloud if you were to attempt to do that? Literally just reading one after the other. How long would that take? 2 hours? Okay. Any more? Go on. Any more guesses? Perhaps a little more? 3? Okay. I'm going to spare you the suffering. It would actually take 12 hours just to read the list of rare diseases if you were to do that. And if you imagine that people can actually devote their whole life to trying to understand and develop a treatment for a rare diseases, that can give you an idea of the task that is ahead of us. In addition to that, these diseases are important because in many cases we know the therapeutic target. We know what we would have to do in order to try to cure that disease, which is not true for many common diseases. And furthermore, a lot of the technology that is being developed in the context of rare disease to treat these diseases is being applied to more common diseases, highlighting further their importance. So what is Rare Disease Day? Is a day that takes place on the last day of February each year. The reason being that on leap years you have the 29th of February, which is a rare day. So on that, people decided to hold Rare Disease Day on the last day of February every year. This year is the 12th edition, and the main objective, as I said, is to raise awareness amongst the public, decision makers, and many other stakeholders, as you can see on that slide. And why are we here at Royal Holloway so keen to celebrate the day? Well, the greatest part of these diseases are inherited, and for them, maybe using genetic and stem cell technology, you can actually treat them. At Holloway, we have an international reputation in this field, so we are very keen to showcase our research and our teaching in this type of outreach activity of which you are taking part today. There are a group of us working in this particular area, and particularly Professor George Dixon will be speaking, will be doing the last lecture today. So you will have an opportunity to hear some of the actual research that goes on here at Holloway in this field. We have very recently set up a center of gene and cell therapy, and our mission statement for this center is to deliver research, teaching, and outreach, like today, in gene and cell therapy, with a focus on rare diseases of the neuromuscular and central nervous systems. I told you that there are loads of rare diseases. We cannot work on them all, so we concentrate on some of them, like muscular dystrophies, spinal muscular atrophy, ataxia telangiectasia, motor neuron disease, but as I mentioned, the technology is also applicable to more common diseases, so we are also working towards treatments for spinal injuries, Parkinson's, Alzheimer's, even antibacterials and antivirals. So taking you back a little bit, I keep telling you that many of these diseases are inherited. So this is a karyotype of the human genome, with a particular gene highlighted in green, which you can just about see. And there may be about 25,000 of those on a very rough count. Each of those genes will normally encode a protein, will have the information to produce a particular protein. If all is well, you have a normal gene and you have a normal protein, but perhaps the gene has a mutation, represented here by that green blob, and then that gene will produce an abnormal protein or will produce no protein. And what can be the outcome of that? Some mutations are irrelevant. They really have no effect, or maybe a particular gene covers for the mutant one and there is no obvious phenotypic effect. Others are minor, so yes, there is an effect, but it is relatively possible to cope with that. And evolution is based on mutations, so our capacity to adapt to a changing environment is based on mutations, so they are important. But in some cases, a mutation can have a devastating effect. And as examples here, I'm showing images of people affected by Duchenne muscular dystrophy and spinal muscular atrophy, both of which are lethal diseases. So mutations in the genes responsible for these diseases can lead to an early death. We have mentioned that it's very important to raise awareness. One of the issues with these rare diseases is that diagnosis can take a long time. In social media lately, I heard that a particular person took 18 years to be diagnosed of the rare disease accurately. So it's a lifetime, and that obviously is a very important issue. But also often these people need very many different types of care, and coordinating that care, which is something that may seem obvious to everyone, is actually not current practice. And to achieve that coordination of care is one of the goals of the day this year, and is part of the theme. The Genetic Alliance UK and their campaign Resist the Rare Disease UK is very active in this area, trying to highlight this need. So is there hope in this massive field of importance? Well, yeah, there are more and more successes in gene therapy clinical trials where new therapeutics are tested in people, and a handful of them have been marketed, and I'll show you a few of those in a minute, in a number of diseases. So both clinical trials and marketed products in these areas, successes in clinical trials in this, and as I was telling you, even application to more common diseases like leukemia for some of the technology that has been developed in this area. And there is an international rare disease research consortium which, given the success in the initial goals that were set up, updated their vision for 2017 to 2027 in such a way that they aim to diagnose all rare diseases and develop 1,000 new therapies by 2027. So there is a lot of work going on and significant success being achieved. What does success in this may mean? Well, this is a real child, a drawing, but it's a real child. His name is Cameron. He's affected by spinal muscular atrophy. And all the children affected by the most severe type of spinal muscular atrophy, type 1, would die before age 2 if they are not treated. And recently, a marketed drug became available, and Cameron and many other children were able to achieve developmental milestones like sitting up unaided and standing up that were unthinkable before. So these new treatments can have a massive effect on people affected. They may not be entirely a cure, but they may have a massive therapeutic effect. These treatments currently come in 3 flavors. So we can engineer viruses in order to deliver genes that can have a therapeutic effect, or we can genetically modify cells so they have a new gene that can have a therapeutic effect, or like in the case of the drug for spinal muscular atrophy, they can be a short nucleic acid that again can have a therapeutic effect. But if you can see the prices, even though they are in euro, there is more or less parity. So where it says euro, you can put down pound. They're massive. So how society is going to cope with the pricing of these treatments that are being developed, when we hear every day that the NHS is at crisis point, is a very important societal issue. So you are here listening to our lectures today. After the lectures, you are going to be attending an exhibition, and you will have a hands-on lab activity to learn a little bit about the inheritance of genetic diseases. And you will have a speed dating activity with undergrads to discuss in small groups a variety of topics of relevance. And you will have a disease detective activity in which you will try to guess what it is that is affecting a variety of people. So a variety of activities during the day which we hope you will enjoy. Just to wrap up, I want to highlight how inspirational the achievements of people affected by rare diseases can be. Over the years, we have had many people affected supporting us. This is Helene Rainsford, who was our patron in 2012, a Paralympic gold medalist. And this is Srin Madipali, who has spinal muscular atrophy, and he was the co-founder of the disabled Airbnb and recently moved to California to develop that company, a person with 2 degrees, really unstoppable. For an event like this to happen, many people have to collaborate, so it's only fair to thank a variety of university departments who help us to run the day, as well as the people, both the staff, postgraduate and undergraduate students here at the university, our exhibitors and our speakers. And you're here to learn. You're also maybe making your university choices. This field is incredibly active and exciting. We can now make defined changes to the human genome, hopefully with a therapeutic effect, and medicine is changing. Genomics is entering the NHS, will be in clinical practice very soon, and artificial intelligence and the handling of the data that are being generated is going to be part of it. So how we understand medicine is changing massively. It's a really exciting time, and I hope that some of you will be enticed to, in some way, participate in this biomedical revolution. So thank you very much. And